Sketch a graph of g of x equals the absolute value of 1/3 x plus 1 as a transformation of the graph of f of x equals the absolute value of x. Let's start with f of x and see how we can transform the equation to turn it into g of x. Now the first thing we can do inside the absolute value symbols, inside that main function, is we can replace x with 1/3 x. So replace x with 1/3 x. Now what that does here, it's going to be a horizontal transformation because it's happening inside the function. It's happening to x. And because we're multiplying by something, it's going to be a horizontal stretch or shrink. But remember, when we're looking at horizontal stretches and shrinks, when we multiply by something that's less than 1, it ends up being a stretch of 1 over whatever this number is. And 1 over 1/3, or 1 divided by 1/3, is 3. So we're going to have a horizontal stretch by a factor of 3. Then, after we do that, to get our final function, we need to take the function that we just had and add 1 to it. That gives us our g of x. So what we did here is we replace our function with the function plus 1. And doing that causes the graph to shift up by 1 unit. So we've got 2 transformations that our graph needs to go through. We know that the graph of f of x equals the absolute value of x is a V shape. We've seen it before multiple times. I'm just going to draw it in. This is the starting function, f of x. Now what we need to do is we need to take points on it, and we need to put them through these transformations. So first, we're going to have a horizontal stretch by a factor of 3. So every point on this graph needs to be stretched away from the y-axis by a factor of 3. So this point is 3 units away from the y-axis. If we stretch it out 3 times that much, it's going to end up being 9 units away from the y-axis. And the same is true for the point on the left-hand side. If we stretch it 3 times as far, it's going to be 9 units away, but on the left. Next, we can look at this point. It's 2 units away from the y-axis. If we stretch that horizontally by a factor of 3, it's going to end up 6 units away from the y-axis. And the same is true for this point on the left. Instead of 2 units to the left, it's going to be 6 units to the left, so it's going to go right here. Now this point is 1 unit to the right of the y-axis. When we stretch this horizontally by a factor of 3, it becomes 3 units to the right of the y-axis, and then the point on the left becomes 3 units to the left of the y-axis. And of course, the origin does not move, so this is what we end up with after the first transformation. We've got a horizontal stretch by a factor of 3. Some of you might even notice this looks kind of like a vertical shrink. It looks like we've taken this and we've pushed it down. We could also think of this as a vertical shrink by taking this 1/3 and pulling it outside of the absolute value, which is something that we could do. We're not going to do that here because we want to keep everything as it is. We want to think of this as a horizontal stretch by a factor of 3. But it is true in certain functions that a horizontal stretch is the same as a vertical shrink. It really depends on the shape of the function, though, and this isn't always the case. Anyways, let's take what we have now and let's go through the second transformation, which is shifting everything up by 1. So if we look at the origin and it goes up by 1, that moves here. If we look at these 3 points and we move them all up 1 unit, they're going to become that, that, and that. And then if we take these 3 points and move each of them up 1 unit, they're going to go here, here, and here. And so our new graph is still going to be a V shape, though that beautiful 90-degree angle is gone. It's turned into quite an obtuse angle. And our new graph is going to be this one. This is g of x equals the absolute value of 1/3 x plus 1. And that is our final answer.